This is the binomial theorem. It is an amazing and exquisite equation that has a lot of meaning, but it can look really intimidating the first time we see it. So first, I want to kind of dissect and unpack what we're looking at. So A plus B is just two numbers. One of them will often be a variable. Sometimes both of them will be variables. And we're raising that sum, that binomial, because it's two numbers, to the power of n, where n is just some exponent, some number 0, 1, 2, 3, 4, and so on. It could be 100, it could be 1,568, any number. And what we're told is that this is a sequence that goes from r equals 0 up to n, where n is the same as the exponent. So notice that this tells us there will be n plus 1 terms, similar to what we saw in the last video. And it then tells us the coefficient is n, choose r. Now, it's been a while since you've seen the notation, this is a combination from our unit on probability. So already we're combining polynomials, like binomials, with sequences and with probability. So we can see really quickly that all of these different fields of math, these different topics that we've studied, are being tied together in this one equation, in this one theorem. So after we have our coefficient, and choose r, we have a raised to the power of n minus r, and then b to the power of r. And so we'll see in a few examples how this works out. The key idea, however, is that the coefficient of a to the power of n minus r times b to the power of r is n choose r. That's really the crux of this theorem. So we want to expand x plus 2 to the fourth power. And so some things to note. In this case, our exponent is n. So n is 4. A is going to be x, b is going to be positive 2. So what our binomial theorem tells us is that this is equal to the sum of r equals 0 to n of n choose r times x to the power of n minus r times 2 to the power of r. So when r, we can even think of this as having a table. We can have r. But even before we set up the table, there's one thing that we can change. We know what n is equal to. N is 4. So we have the sum from r equals 0 to 4 of 4 choose r times x to the power of 4 minus r times 2 to the power of r. So we can make a table here. So our numbers for the table, 0, 1, 2, 3, 4. That's our table. The first thing, and I'm going to use some various colors to help us keep this organized, is 4 choose r. So 4 choose 0 is 1. 4 choose 1 is 4. I've done probability enough that I remember many of these, but as we start getting up to things like 2, it behooves us to remember that we can also put this into our calculators. So 4 choose 2. I'll find my probability numbers. 4 choose 2 is 6. And then notice that we got to the halfway point, so we're going to start decreasing, 4 and then 1. Then in green, we now want to have x to the power of 4 minus r. So we'll have x, 4 minus 0 is 4. Then 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 1, 4 minus 3 is 1. And then 4 minus 4 is 0. And then let's go to a darker shade of green. We now want 2 to the power of r. So 2 to the power of 0, 2 to the first power, 2 to the second power, 2 to the third power, and 2 to the fourth power. And now we get to simplify. And this is where I'm going to go back to the color red. So we have anything to the 0 power is just 1. So we have 1 times x to the 4th times 1. So that just gives us x to the 4th. Then we have 4 times 2, which is going to be 8 times x cubed. Then we have 2 squared, so 4 times 6 is going to be 24, plus 24 times x squared. This is going to be 4 times 8, which I believe is 32. So 32 times x, plus x to the 0 power is just 1, and 2 to the 4th power is 16. So this would be our fully expanded polynomial. Instead of multiplying x plus 2 times x plus 2 times x plus 2 times x plus 2, but the binomial theorem allows us to reduce that into a much smaller set of calculations that combine what we learned from counting and probability with what we know about exponents and sequences. This also allows us to figure out the coefficients of certain terms. So maybe we're not interested in many terms of the whole thing, we just need to know one. So for example, if we want to know the coefficient of x squared times y to the 5th in the expansion of the binomial product x plus y to the 7th power, then we need to identify, well, n is 7, r is going to be 5. And so we're going to have, for this term, n choose 7 times x squared y to the 5th. And I said that incorrectly. If I could rewind time, it would be perfect, but I can't. What I had meant to say was n choose r, which is 7 choose 5 times x squared times y to the 5th. I don't know 7 choose 5 off the top of my head, but I can use my calculator to figure that number out. So 7 choose 5 is 21. So the coefficient of x squared times y to the 5th in this expansion is 21. We didn't have to multiply x plus y 7 times itself 7 times. We were able to just use this theorem to relate it to some probability and find the answer. Likewise, if we wanted to find the coefficient of x to the 5th in the expansion of the binomial product 3x minus 4 to the power of 8, we can do this. So let's start by saying we know n is equal to 8. And so if we want n minus r to equal 5, we have 8 minus r is equal to 5. If I add r to both sides, we have 8 equals r plus 5. Then subtract 5 from both sides, we get 3 is equal to r. So that tells us the values that we need to use in our theorem. N is 8, r is 3. Now we're not doing all the values of r from 0 to 8, we're just doing the value of r that's equal to 3. So let me change color. Let's do this. Let's do this one. We'll be adventurous. So we have n choose r, which is going to be 8 choose 3. We then have a to the power of n minus r, which is going to be 3x all to the power of 5. And then we have b to the power of r, which is going to be negative 4 to the power of 3. Now, the reason the negative sign has to be here is, notice in the theorem, we have a plus sign. So if we have a negative 4, that means b is actually negative 4. So now we have to simplify. 8 choose 3 is 56. Recall that if we have 3 times x to the 5th power, that's equal to 3 to the 5th power times x to the 5th power. So 3 to the 5th power is 243 times x to the 5th times negative 4 to the 3rd power. It's going to be negative 64. So now I get to use my calculator, because I don't want to multiply these numbers. Do 56 times 243 times negative 64. And the number I get is negative 15,496 all times x to the 5th. And this is our answer. In fact, to be even more precise, since it was asking for the coefficient, our answer is really just this negative 15,496. So that wraps up this video. In our next video, we will look at an alternative method to calculate binomial expansions.